students, in this video we are going to talk about the physics class 12 optics, which we are going to discuss the geometrical optics chapter 9 according to NCERT book. So I'm not going to talk about any NCERTs based, but I'm going to talk about the JE based questions, a JE based concept, one important concept of the relation between the object and image velocity. So let's see that. So this is we are going to talk about, see, this is the quite important concept in when we are discussing about the JEE mains with respect to JEE mains, as one question is sure shot coming from this concept, which is relation between the object and image velocity, and it is advanced topic also. So in this video we'll discuss through points by taking cases. So first will be the general cases, which is case 1. Let's consider that as case 1. So in this we'll simple use the mirror formula to find the relation between the image and object velocities. The case 1 will consider as the general case. All right. So in general case, we'll take the mirror formula, which is quite simple: 1 by e plus 1 by u equals to 1 by f. And for finding the relation between the object and image velocity for general cases, we'll simply differentiate the equation with respect to time. So let's differentiate it. So this is minus 1 by v square into dv by dt minus 1 by u square into du by dt, which is equals to 0. Now you guys will think about that why I have taken 1 by f differentiation as 0. So let me tell you that 1 by f differentiation is taken as 0. The reason is that the focal length of for a mirror, let it be concave or convex, is always constant, but the velocity, and that is the image distance and object distance is never constant for the topic which we are discussing, as the object and image are constantly in motion. So we cannot consider the image and object distance as constant. Hence we'll make sure that the differentiation is correct. So now we'll consider that dv by dt is equal to, that be equal to velocity of image, and du by dt, let that be equal to velocity of object, let that be object be om. All right. So from here, by substituting the VIM and VOM in the equation, let that be 1, what we get as that it is equals to minus 1 by v square into, let that the dv by dt is v into im, minus 1 by u square into du by dt we can write as v as om, that is equals to 0. Now what we'll do is we'll shift this part to the right hand side. Now let's see what we get. All right. So this is here minus 1 by v square into VIM is equals to 1 by u square into VOM. From further manipulation, we can write as velocity of image is equal to minus v square by u square into velocity of object. All right. Now we know one thing, that v by u minus v by u is equals to magnification. V by u. All right. Magnification is equals to v by u. So here we can write velocity of image equals to minus of magnification square into velocity of OM, that is velocity of object. So this is the second equation which we have arrived at. Now here students, you can see that the magnification is minus of m square. The negative sign simply means that if u is decreasing, that is the image distance is object distance is decreasing, then the image distance will increase for sure. That is, if real object approaches the mirror, its real image will recede from the mirror. So let's take, if in this case, if we consider the magnification as mod of m as 1, then what we'll get as that the dv by dt, mod of dv by dt is always less than mod of minus du by dt. This is for general case. So here this is what we have arrived in general case result. Let that be equation number 3. So for any of the cases, we can say that the object velocity is always less than the image velocity with negative sign. All right. Now we'll consider the some more cases. Let's see the case 2 and case 3 and we'll get the conclusion. For case 2, we'll consider when the object, that is u, distance that is u, moves between the center of curvature and the focus. See students, you simply have to remember these results. These will be highly helpful for you in the further examination. Okay, let's see. So in case 2, if we consider the object which moves between the center of curvature and the focus, so in this case if we consider mod of magnification as 1, then what we get is that, hence we can conclude that the image velocity is greater than mod of negative of object velocity. Alright, then we'll move to the next case. We'll move to the next case. In this case, if the object moves between the focus, that is u, is between the focus f and pole of the mirror. Alright, so in this case, the very first thing, that the image will be virtual. Hence what we can say, that according to the mirror formula, this is 1 by v, so this is plus v plus 1 by, this will be minus u, as the image is virtual, and this is 1 by minus of f. So what we can simply, by differentiating again this equation, we'll get as dv by dt is equals to v square by u square into du by dt, or we can write as dv by dt is equals to m square into dv by dt. So we can arrive at, this is the formula, let this be equation number 4. So here what we can conclude, that if u is decreasing, then v will also decrease, which means if real object approaches mirror, alright, the image will also do so. Approaches the mirror, image will also do so. Okay, note that here dv by dt and du by dt are not the velocities with respect to the ground, but are the velocities with respect to mirror. Alright, so it means that when the mirror is at rest, then velocity of object or image with respect to mirror is same as velocity of object or mirror with respect to ground. Then velocity of image or object with respect to mirror is equal to velocity of image or object with respect to ground. Guys, do subscribe to my channel. I have no sponsors, and YouTube is not supporting that much, or that might be the case that I've started the channel recently. So please support my channel. Do subscribe. Thank you for watching.